If you're solving a trig equation and it has more than one angle, then your first step should be to try and make the angles the same. So you're going to do that by using the compound angle formulae. Now these are on your formula sheet, but remember that you have the version of them that says the sine, cos or tan of, say, alpha plus beta. It doesn't say the sine, cos or tan of 2 alpha. So you need to generate those ones as you need them. Now my other tip is take care with the domains. So let's see how to do this with an example. Here we're solving tan 4x equals negative tan 2x, and it's only in this domain where x has to be between 0 and pi on 2. Now straight away I can see that if I decide to work in 2x here, then actually let's put this in green as a reminder, 2x is basically going to be doubling this, so I need to double that and double that. So I know that 2x needs to be between 0 and pi, so I need to keep that in mind. Now, again, I'm going to do some thinking over on the side. Now, can I come up with an expression for 4x, tan 4x, that's in terms of tan 2x? Now, a slight word of caution, a few of you who can do a lot of these things in your head might feel frustrated. Feel free to speed up the video, but I'm going to do every single step so that I don't leave anybody behind. So if I'm looking at my reference sheet and feeling stuck, first thing I'm going to look at, now you wouldn't write this out, you're just going to look at it, but what you're going to see is that the tan of alpha plus beta is equal to the tan of alpha plus the tan of beta over 1 minus tan alpha tan beta. That's what you'll find on your reference sheet. So underneath that, or perhaps in your working area or on the side of your page, you could say, hey, if alpha and beta are both theta, then the tan of 2, in fact, let's let them be x plus x, we're going to have the tan of 2x, then I'm going to have here the tan of x plus the tan of x, well that's going to be 2 lots of the tan of x, and 1 minus tan x times tan x, that will be 1 minus tan x all squared, which I can write like that. So now I've got that, I could throw all this in over here, but is that going to help me? No, because all I'll have done is change tan 2x into terms of tan x, and that's not going to talk to the 4x's at all. So what to do? Well, if we can do the tan of 2x here, why don't we just change it to the tan of 4x? Now, if I've doubled this angle, I need to just double these angles. So that's going to give me tan of tan 2x over 1 minus the tan squared of 2x. I'll put that in brackets there just to keep it simple. Now, notice that my numbers out the front all stay the same. The only thing I doubled here is the actual angle that I'm taking the tan of. So instead of tan x, I've got tan 2x. Now I can use this because I can substitute in for tan 4x all of this stuff, which has tan 2x in them, and that will speak to the other tan 2x's, and I've got the same angle everywhere, it's 2x. So let's take all of this and put it in for the left-hand side. Now, you might not have needed to do much of that working on the side, but if you did need to do it, don't beat yourself up. Just do that working and you'll be sure of what you're doing and you'll feel like you know where you're going. So we're going to write all this out. We've got tan of 2 tan 2x over 1 minus tan squared 2x is equal to negative tan 2x. Now again, you can probably do some of these steps here in your head. I'm going to do every step so that I don't leave anyone behind. If I want to get rid of this fraction, I just multiply both sides by the denominator. So I get the same stuff at the top here, and over here I've got minus tan 2x multiplied by 1 minus tan squared 2x. Now let's expand the brackets. Again, if you're frustrated, bear with me. I've got minus tan 2x, and a negative makes it plus. So I've got tan cubed 2x here. Okay, so we've got tan 2x's, and tan cubed 2x's. So let's add tan 2x to both sides. That will give me 3 tan 2x's here. And we can subtract tan cubed 2x, and that will leave us with 0. Now, the reason I'm doing that rather than leaving some things on each side is that I don't want to divide by tan 2x because that stops tan 2x being allowed to be 0. So never divide by your pronumeral, or in this case by the tan of our pronumeral. Now I can factorise. So I can bring tan 2x out the front of some brackets, and I have 3 minus tan of 2x squared instead of cubed because I've brought one lot of it out the front. So that means, we're going here, we can still see, that means that either tan of 2x equals 0 or tan squared 2x equals 3. Now, remember that what this means is the tan of 2x all squared. Okay, so you can write it the way I had it, you can write it the way I've got it now, or you can even see that in your head or just copying down underneath. That means that the tan of 2x is root 3, or the tan of 2x equals negative root 3. Now let's solve each of these three separately, and then we can bring our answer together at the end. Now, if I'm thinking the tan of something is 0, I know that the tan of 0 is 0, so clearly 2x could be 0, but I also know that the tan of pi is 0. 0, pi, 2 pi, 3 pi, going across like that. So pi is another possibility for 2x. Halving both of my answers there, well, half of 0 is still 0, and half of pi gives me pi on 2. So I've got those two solutions there. All right, the tan of something is root 3. That's one that I know. The tan of 60 degrees is root 3. So 60 degrees, that's pi on 3, working in radians. So I can say that 2x could be pi on 3. But for tan to be positive, that happens in the first and the third quadrant. So the third quadrant answer here would be pi plus pi on 3. That's going to give me 4 pi on 3 as the other possibility. Now to find what x could be, I just need to halve both those answers. So instead of being thirds, they could be, well, pi on 3 if we halve it is pi on 6. And 4 pi on 3 if we halve it gives us 2 pi on 3. So I've got two answers there. And now for this last option, I've got tan of something is negative root 3. Well, that's going to be a lot like 60 degrees or pi on 3, but we want tan to be negative, and that happens in the second and the fourth quadrants. So the second quadrant equivalent of this would be 2 pi on 3, and the fourth quadrant equivalent would be 5 pi on 3. Now, some of these are going to be the wrong size. I can see that now. So I'm coming up with some potential solutions, and I'll get rid of the ones that are too big. So halving both of these, I get not 2 pi on 3, but just pi on 3 and 5 pi on 6. Now, way back here, we saw that x had to be between 0 and pi on 2. So I could have really discounted this answer as being too big because 2x needs to be between 0 and pi, and that's too big. So clearly this one's also too big. And here, this one's too big, and so is this one. Now, if you've done a little bit of work and then you say, oh, silly me, I should have realised, it's much easier to do a little bit of extra and cross it out than to have not thought of a whole quadrant altogether. I mean, yeah, I can hear you, why waste time with something, but that's slightly better and getting the answer right than missing a whole solution because you just didn't think of the other quadrants. So now I can bring my answer together. I've got 2 here, 1 there, and 1 there, and my final answer is that x could be 0. Nice to list them in ascending order, I think. Pi on 6, pi on 3, or pi on 2. I've got 4 solutions. Now, if you want to check your solution, go ahead and put these in, make sure you're in radians mode though, and say the tan of 4 lots of this should equal negative the tan of 2 lots of that. It might even be easier to put these in degrees mode, knowing we've got 90 degrees, 60, 30, and 0, and say, is the tan of 4 lots of whatever that is equal to the negative? And you can always check your answer. Now, in an exam, you wouldn't want to do that. Unless you've got to the end, you're sitting there thinking, well, I've finished this one. Go ahead and check your answers then if you've got the spare time.